With this problem, this is going back to what we were looking at in Unit 2, which is just a bunch of stuff related to unknown angles and using rules that we know about angles. So the first thing I wanted to do is, if we look at this, we want to figure out the angles that we already know. CAD, which is this angle right here. You can see the C, the A, and the D if you follow those 3 points. A is the vertex. This is 76 degrees. BCD is that angle, which is 47 degrees. And CBG is this angle right here, and it's 140. So I'm going to just kind of walk through one way you could have thought through this problem, and then I'm going to show you the way that I did it, which is the slightly faster way, and maybe you did it the same way as me. So you might have noticed that these are linear pairs, and then you could solve for this angle if I called it x. Then at that point, we know 2 of the 3 angles I could then solve for angle y. Because I can take whatever we solve for x, plug it into our triangle sum theorem. I know that these 3 angles, x, 47, and y, have to add up to 180. So as soon as you know what y is, then you can say, hey, I've got a linear pair right here, and I'm going to call this z. And then once you know what z is, because you just have to do y plus z equals 180, because they're linear pairs, then you could do 76 plus z plus, we'll just call this one right here, the angle that we're looking for, I'll just put an A. That's the angle we're looking for. So I could do 76 plus Z plus A, have to add up to 180. Now, when you do this, this is 4 calculations. You have to do your linear pair calculation. Then you have to do your triangle sum theorem calculation right here. Then you have to do another linear pair calculation. And then you have to do your triangle sum to get your last one, which isn't that bad. You can do it. And if you're quick enough with these concepts, you can get that done pretty quickly. But we're going to do this a little bit differently. I'm going to show you how I did it, which can save you a little bit of time. Again, if you have the time to do it the other way, then you don't need to worry about going faster. But I just wanted to show you this as a reminder. One thing that we learned is that we have an angle relationship called exterior angles of a triangle, which we just abbreviated as EAT. And that means that this angle equals these 2 opposite interior angles added together. So what I can do is I can say that 140 degrees equals 47 degrees plus, I'll just call this angle x. And then I can go ahead and solve, do the algebra. X will equal 93 degrees. So if I erase this real quick, 93 degrees. Now that I have 93, I can also do another shortcut. I can realize that, let me change colors again, that this angle right here is also an exterior angle for that angle. So when we're talking about exterior angles, this angle is, if I took this line and projected it out, like I did there, then I create an exterior angle, and it equals the 2 opposite interior angles added up. So 93 degrees has to equal 76 degrees plus, I'll just call this y, and that's what we're really solving for. So when I go through and do this, y equals 17 degrees. All right, so your answer is going to be H or C in the way that we put it in. So there are multiple ways of looking at this, and it's up to you to kind of figure out which one makes the most sense for you. I'll clear that and we'll move forward. So we are doing one of the most, it's a very foundational skill for a lot of things that you do in more advanced math, and it's factoring quadratics. And we're going to be learning that this week. You will have some kind of an assessment on it next week. Exactly what that looks like, I haven't determined yet, but you will basically just be spending every day this week practicing with this. And today is going to be a longer day because we're going to learn more or less the full process. Anything that we add from here is just going to change the process a little bit. But it's going to be quite a bit to try and get in one day. So when we're talking about factoring quadratics, that means when we're doing things in the opposite direction from what we did on Thursday. We multiplied some binomials, and this is also called a trinomial because look, you can see 1, 2, 3 terms. So this can also be called factoring trinomials, but we're going to be, if it's called a quadratic if the degree is 2, but you could have a trinomial that has a different degree. Anyways, we're not going to worry about that part. That's actually more algebra 2 type stuff when you get into that. So we're going to be dealing with everything that has just x to the second power. And on Thursday, we looked at stuff like this: x plus 4 times 2x plus 1. And we were able to multiply this out. So if I multiplied that out, that would be 2x squared plus x plus 8x. Whenever now I'm doing this one being distributed out, 8x, and then plus 4. And then I can combine my like terms in the middle, and I get 2x squared plus 9x plus 4. Okay, and I want to leave that up here. This is not the problem we're doing currently, but I want to draw parallels to this. Because now what we're going to do is we're going to start with this one, and we're going to work our way up backwards and figure out how to get the original factors if I give you a quadratic. And one of the first things that we need to kind of get down, and I mentioned this on Thursday, is that you have ax squared plus bx plus c. This is the standard general form of a quadratic equation. And the important thing is that we notice that we can identify what our a, b, and c terms are, because that's going to be really important for what we're about to do. So a equals something, b equals something, and you need to be able to identify what those are. So let's just practice with this one real quick. A equals, b equals, and c equals. I always encourage you to start off with this. So what would your a equal for this quadratic that we're working with?
1.
1. B equals,
6.
and then 5. Everything that we're doing today, I'll give you the heads up on this. Everything that we're doing today, our a value is going to be 1. That's where we're going to start. These are the simplest form of quadratics. And we will build up from there. But again, if you can do the a equals 1 quadratics, the other ones aren't more challenging. This just adds a little bit. You have to kind of look at it slightly different way. Well, we'll get to that. Okay, but I don't want you to freak out about what's coming. So now that we've identified a, b, and c, this is going to be the method that we use. Notice I'm drawing this big X. And what I want you guys to do today is have your own sheet of paper out. So if you don't have one available right now, go ahead and get one out and follow along with this, because I'm going to ask you to do a lot of this work on your own. And you certainly want to have some examples to follow along with later. So you'll notice that I drew this big X, and this big X is for organizational purposes only. You can organize it different ways if you really want to, but I think you'll find this is a nice way of just keeping things straight. So we've got this big X, and we want to think of this as a house for our kind of mnemonic device purposes. Imagine this X is a house. And if you were down in the valley, of course, if you had an AC unit, typically your AC could sit on the top of your house. Sometimes it's on the side, but we're going to say the AC unit sits on the top of your house, and down at the bottom, you have your basement. Okay. Now, the reason it's just a mnemonic device, because what we're going to do is we're going to take our A and our C terms, we're going to multiply them together and put that value at the top. So what's A times C for us in this problem? 5. And our B term goes at the bottom. So what are we going to put there? 6. So no calculation required. We just put the B term at the bottom. Now I'm going to add this as well. This is going to be a little dot to mean multiplication. And this is a plus sign to show addition. And this is just to remind us that what we're looking for is going to be factors of 5 that when I multiply them together, I get 5. When I add them together, I get 6. So what are the factors of 5 that you guys know? 1 and 5. And this one is a very simple problem because we only have 2 factors of 5. Will these multiply to give us 5? And will they add to give us 6? Okay, so it starts off very straightforward. We're good to go. So going back to this problem right here by way of analogy, we started with this quadratic. And the next step is to turn it into a quadratic that looks like this. So what we're essentially doing is taking this b term in the middle and we're going to split it into two different terms. And that's what we just found. We found the two numbers we need to use to split our b term into two different terms. So imagine in this case, I'm following the same quadratic, but I'm going in the opposite direction. So I'm going to try and squeeze my work in on this page. And I just want you to kind of see the parallels between the original work we did on Thursday and what we're doing today. So I've got x squared plus 6x plus 5. Now I'm going to split this into, and it doesn't matter the order I do this, x squared plus, I can put the 1x plus 5x plus 5. So again, it doesn't matter. I could have put the 5x first, but it is important that you split it up that way. So essentially, we're taking our b term, we're splitting it up. I could recombine these two back together and make it 6x, but that's not what we want to do because we're factoring. So that was a lot to digest, that much right there. Again, you might have actually gotten this far last year in algebra where you remember seeing this, but maybe some of you didn't. So for right now, we're not actually done factoring, but I just want to get to that step. So all I want to focus on right now is going from the first step to the second one. And then in a minute, we're going to figure out how to go back to the second step to the third. So what I want to do is I'm going to erase some of this real quick. I'm just going to erase the entire screen. So hopefully you have the stuff copied down. We're going to come back to this, but I'm going to lose it off of my screen for now. We're going to do another problem. I'm going to skip over this one. And I wanted to look at this problem because now we have a negative being introduced. So the first thing to do before I worry about anything else is just to identify our A, B, and C terms. So what's A? B? C? -10. Okay. Big X. And you'll figure out how big to make this X, just for your own writing to make it work for you. A times C goes up top, B at the bottom. We're multiplying for the top part and adding for the bottom part. So if I multiply A times C, what do we get? And then 3 down here. So the next thing I want to do is I want to get the factors of, I know it says -10, but let's just get the factors of 10. And what I like to do is I like to start at 1. Because 1 is always a factor of everything. 1 times what gives me 10? 1 times 10. What's the next set of factors? 5 and 2. So I like to, and just my general way of going through it is I start at 1, and then I go to 2, and then 3, and then 4, and then 5. And I just think this 1 is always a factor. Sometimes 2 is, sometimes 2 isn't. Same with all the other numbers until I get up to a certain point. And I'll talk more about that on another day. But basically, I just start at 1 and work up. So here I have 1 times 10, 2 times 5, and those are the only factors. So what I want to think about is this is a negative product. So how do you end up with a negative product? One of the factors has to be negative, one has to be positive. So what combination can I make with my factors to where one of them is negative, one of them is positive, and when I add them together, I get +3. There it is, -2, +5. So this is the part that you need to kind of use your own thinking process to get through. I don't really have a shortcut for this part, but you just look at all your factors and you kind of think to yourself, if it's a negative product, I'm going to have a negative and a positive. So which one can I make negative so that the sum of them equals B? This one isn't too bad because we only have 2 sets of factors to deal with. All right, so we're good to go. So now x squared plus 3x minus 10. My next step is to split this b term into 2 different terms. This stays the same, x squared. This stays the same, minus 10. So now, how I split the next part up doesn't matter if I put the -2 or the 5 first, but they're both going to be with an x after them. So it's up to you if you want to make it -2x plus 5x, or you could flip it. You could have the plus 5x first, and then the minus 2x. And it's minus 2x because, of course, we have a negative 2. All right, are there questions on this one? Okay, so let's, assuming that everyone has gotten this and that you're copying this down, we are going to come back to all these problems, so it's important that you're copying the stuff down, because when we come back to it, we're going to finish out the factoring. But I'm going to erase my screen, so we're not just going to do all of it right away. Okay. So let's look at one more right here. So I've got A, B, and C. I want you guys to just write on the screen what those values are going to be. You can even start filling in our big X. There it is. So let's come up with all the factors of 12, starting with 1 times what? 2 times, and then 3 times 4. And I know that's where I can stop. Just kind of as a shortcut, I know where I stop is at the square root of 12. Once you get to the square root of 12, which is not a rational number, it's going to be like 3 point something. But as soon as you get up to 3, you don't have to keep going up to 4. All right, and you can already see 4 is on the other side of this. So that's kind of my trick so that I can keep myself organized. Because if you have a bigger number, like let's imagine that the top of your X was like 144. Now we know some of the factors of that, but there could be a lot of factors. So to keep it organized, I'd start 1, 2, 3, all the way up to 12 times 12. All right, and that's as high as I need to worry about going. So as big as a number gets, you only need to go as high as the square root of it on the left side. All right, that's not this particular problem, so I'll get that out of the way. So now what we're looking at is a situation where we have a positive product and a negative sum. How do we get that? Both factors have to be negative. So which two factors are we looking at? 3 and 4. If I make those both negative, then sure enough, I get a positive product and I get a negative sum. And now you guys can go ahead and write the next step. Oh, that should be 7x right there. I forgot that typo exists. Okay. So at this point, go ahead and write in the next step. Okay. There it is. And again, if you want to switch it up and put the negative 4x and then the negative 5x, that's totally fine. So what are negative 4 and negative 3? I don't know what I just said. I'm sorry. X squared minus 4x minus 3x plus 12 is the same thing. We're going to get the same answer no matter what. So we're good with either one. Okay. So with this, I'm going to show you guys 2 more quadratics. I want you guys to find space on your page to write both of these down and just do this much. Get through the big X and find out how to split your B term into 2 terms. All right, so if everyone's good with this, let me go back. Here's one of them to write down. So just write down x squared minus x minus 6 on your page. And then we'll show you another one in just a few seconds. Okay, the last one is x squared plus 4x plus 4. So take some time, just do the big X for both of those and figure out the splitting of the B term, and then we'll come back together in a couple minutes. Okay, so let's do this. I'm going to put this down, x squared plus 4x plus 4. And someone feel free to write in the next line of your factoring. next line of this process. There we go. That's okay. We can double up, that's fine. Okay. Now, of course, 1 and 4 are also factors, but because they don't add up to 4, we don't care about those. And truth be told, if you know what the two factors are supposed to be, you don't have to list all of the factors. But there's going to be some problems where it's going to be hard to know which ones unless you list all of them and really go through, one pair at a time until you figure out the right ones. So just understand that how to do that in case you need it. Okay, so we're good with that. I like that. That's what I got as well. So if you want to make sure yours looks the same, x squared plus 2x plus 2x plus 4. I'm about to move ahead. Okay, I'm going to take on faith that you guys at home are following along, doing the same thing. All right, I'm going to clear this. And let's look at this one. So if I have x squared minus x minus 6, I'll go ahead and fill this in just in case you made a mistake. People can fill in this big X for us as well. And let's just see what you guys came up with. Okay. Again, you guys had enough time, so hopefully you guys all came up with the same answer and you understand how this was arrived at. 1 and 6 are also factors of 6, but we don't care about those. 2 and 3 multiply to give us 6, so you just have to figure out which one gets the negative. So this all works out. 2 times negative 3 is negative 6. 2 plus negative 3 is negative 1. So we're good with these two. And the order doesn't matter. So if you had written this as x squared minus 3x plus 2x minus 6, you're still in good shape. All right, so let's just move on to the next step, starting with this one. Everyone has gotten to this point with all 5 of our quadratics so far. And this is kind of the halfway point. And from here, what I'm going to do is set up what's called a Punnett Square. It's just a box like that. And if you need to make it bigger to make sure all your numbers fit, what I'm going to do is I'm going to fill this in kind of in this order right here. I'm going to start with my x squared in the top left, and then go to the right, put my next term, go to the bottom left, put my next term, and then the negative 6 goes at the bottom. Yes, I will talk about that shortcut. But we're going to kind of go through this full process. So I'm going to go ahead and write down the x squared minus 3x plus 2x. And whenever it's a minus 3x, I want to make sure I put a negative 3 in there. All right, and then I get minus 6. So again, a negative 6 goes right there. Okay. So what the process is, and you can see in the chat, someone shared that there's a shortcut when a equals 1, and that's absolutely true. But I want you guys today to be familiar with the full process, because when a does not equal 1, then there isn't a shortcut. So you have to do it this way. So if you're getting familiar with it right now, that's a good thing. So the process from here is figuring out for every row and for every column in our Punnett square, what is the common factor? So let's start with the rows here. What's the common factor between x squared and negative 3x? 1x. So think of it like this. I have x times x, and then negative 3 times x. Both of these have x as a factor, so I can pull that out. All right, that's the idea that we're going for here. So the common factor here is x. What's a common factor between 2x and -6? All right, 2. And what I have here is 2 times x, and then 2 times -3. So in this case, 2 can be pulled out. So let me go ahead and write that down. I've got 2. So now I want to look at the columns. So what's a common factor between x squared and 2x? 1x, the same thing as kind of the first one row that we did. So this is going to be x as a common factor, and between -3x and -6, what's the common factor? -3. Remember, this is just -3 times x. This is -3 times 2. So there we go. That's a common factor between it. All right. Now, if you're wondering, when should you pull out a positive factor? When could you pull out a negative factor? You want to get your x term. Oops, that's not what I meant to do. You want to get your x term to be by itself. So here I'd factor out a -3. Here I would factor out a +2. So anyways, what we've just created are our two factors. I've got x minus 3 is one factor. And then right here, that's x plus 2 is a second factor. So notice we went from this quadratic right here to the factors that will multiply to give us that quadratic. And that's it. That's all we have to do. And that's all we're going to be focused on right now. We're going to work on factoring only. And then when you get to algebra 2, you will do some more with this, quite a bit more, in fact. All right, so let me clear this, and we'll talk about the shortcut in just a second, but I want to go through another one of them. Let's go back to the original problem. So we had gotten to this point where we had x squared plus 6x plus 5, and then we had x squared plus x plus 5x plus 5, and now we need to create the Punnett square. So I'm just going to take the first one, plug it in there, then there, there. Okay. So this is what I've got. Okay, let's do the rows first. What's a common factor for our first row? X. And the common factor for the next row? 5. Common factor for the first column? And what's a common factor for the second column? 1. Okay, this is one it's a little bit tricky because x and 5 really don't have anything in common except for the fact that this is 1 times x and that's 1 times 5. 1 is always a factor if you have nothing else. So in this case, we don't have anything else. So I will do 1 as a common factor. All right, so at this point, when there's no sign given, it's positive, right? So this is a +1 and that's a +5. So my two factors are given right here. X plus 1 times x plus 5. All right, and the shortcut that was mentioned before looks like this. When you do your big X and you have your a times c up top and your b at the bottom, and you come up with the right factors, 1 and 5, notice that we had 1 and 5 as our factors, and we end up with x plus 1, x plus 5. So the shortcut is I can just take this, and I can have an x plus, and I can just take this and just drop it in. So that seems like, oh, why are we going through this process of the Punnett square? Well, like I mentioned, this Punnett square doesn't work if your a is something besides 1. So it's a good shortcut to know, but don't become reliant on it because it doesn't always work. Okay. Are there questions on this so far? Okay, let me clear the screen. And yeah, let's just go through the 3 remaining ones. So we had gotten, I'll go ahead and write this in again, x squared plus 4x plus 4. You guys already have this on your paper, so I'm just getting back to what you have. So I'll just put the Punnett square over here. Go ahead, fill in the Punnett square. Anyone can write on the screen and put in the common factors between them. And I apologize, I totally was working too fast. That should have been a 4. Okay, so you got this much. Go ahead now. You found your common factors between them. Go ahead and write out what our final factors of this will be. And there it is. Remember, the place we're finding this is the tops of the column and the side of the rows. We're just seeing what we have. So that's x plus 2 and x plus 2. It's a plus if we don't see a negative pulled out. So if there's a negative, technically what we're saying is x plus a negative 3 like we saw before. But anyways, that's the idea behind this. Let's try another one of them that we did. I'm gonna clear these drawings. We already did this one, so let's give that one a go. And I'll just fill in what you guys already had to begin with. And again, you might have had minus 3x first, but it won't matter. There you go. You're drawing that Punnett square already. All right, you guys can go from there. So this is a good one to look at because this is another one of those situations like, in this case, do I pull out a 4 or a negative 4? Because I see a positive and a negative term. We want to figure out when you have the variable term, how do I make that just a regular variable? So I would pull out a negative 4 in this case, and also for this row. Since it's a negative 3 right here, I would pull out a negative 3. So I'm pulling out a negative in both cases. It's going to be x minus 3, x minus 4. You can see right there, because it's a negative, we have the minus 4. Okay, and that's it. You guys have got it done. There was one we didn't do. Which quadratic did we not do yet? Or did we do all of them? Let's look at this real quick. Did we do this one yet? We started with this one, right? We didn't do this one. Okay, so let's just, for completeness sake, just to make sure we can see what all the possibilities are. So x squared plus 3x minus 10 became x squared plus 5x minus 2x minus 10. And that's, again, what you guys already have on your paper, so you guys can work from there. All right, this got done pretty quickly. And you can see the x minus 2 that we got by looking at the rows, x plus 5 that we got from looking at the columns. And again, the order here at the end doesn't matter. So if you'd put your x plus 5 first, and then your x minus 2 second, that doesn't change a thing. But it will need to be a positive 5 and a negative 2. So we're looking, just to say it one last time, in a column like this, I'm saying because that's a positive 5x, I want to pull out the positive 5. So I end up with a positive x value. Okay, so that's the idea behind this. And we will see a little bit more nuance in exactly how to address this when we get to terms where this is not just 1x squared in the top left. So anyways, that'll get a little bit trickier, but not much more. You already know the basic process, so I just wanted to spend a little bit of time. Let me clear this and show you what your homework looks like. So it's going to be in Delta Math again. We haven't been there in a while, but we now will be going back to it. All right, so let me first of all go to this. You're going to be doing just the big X. You're going to have 5 problems where you just have the big X. You need to fill it in. And notice it gives you the same kind of visual cues that I gave you with the dot. I mean, they're using the X, but it's the same thing, multiplication. So I want to think, what can multiply to give me 10 and add to give me 11? And for some of these, this one's not the most challenging one. Some of them have really weird numbers. So if I switch, well, let's go ahead and answer this one. What are the 2 factors going to be? 1 and 10. And if you know it right off the top of your head, then just put those numbers in and you're good to go. And you can see right here that those will satisfy that condition. Let me see if there is another one. Okay, now this one you're probably not just going to do in your head. So here you're going to need to figure out what are all the factors of 91. And we didn't see anything like this in our examples that we did as a class, but there are factors of 91, and 7 and 13 end up being factors. So eventually you could say 1 times 91. Well, that's not it. 2 isn't. 3 is not a factor. 4, 5, 6. So actually, that's about it. 7 and 13. So eventually, if 7 and 13 are the ones we're working with, what's going to be positive and negative here? So maybe I could write it this way. All right, so let's try a negative 7 and positive 13. Now, I don't expect you guys to know those are factors of 91 off the top of your head. So what you're going to need to do is you're going to need to do some guess and check. Is 1 a factor? Of course it is. 1 times 91. Is 2? No, it's not. And then you can try 3, and then 4, and then 5. Eventually you'll find 7 can be divided evenly. I just do 91 divided by everything until I get to 7, and I'd get 13 as my answer. So then I could try this. So let's try negative 7 and 13, because I can see that these two will add up to 6, and they'll multiply to give me negative 91. All right, so there we go. Some of them will be more challenging. Some of them will be ones you can answer in your head. Just go through the big X about 5 times with that, and then you're going to have problems where you have to go through the full process. All right, so in this case right here, we'll just do one last example, but I'll just do this one quickly. Maybe you can ignore what I'm saying and try it on your own, see if you come up with it. So A equals 1, B equals 11, C equals 28. The full process now means I'm going to set up a big X with A times C at the top, B at the bottom. So that's 28 at the top, and that is 11 at the bottom. And now I need to figure out what are the factors of 28. Well, 1 times 28, 2 times what? 14. 3 is not a factor. You could try it if you didn't know that, but I'm going to skip 3. 4 times what? 7. And then I think that's it. So at this point, which 2 are we using? 4 and 7. They're both positive because we get a positive product and we have a positive b value. So now I can do this. X squared plus 4x plus 7x plus 28 means my Punnett square. Of course, you know your answer with the shortcut is going to be x plus 4 and x plus 7. All right, because I can just take those and call it good. But again, just to get practice with the Punnett square, I could do x squared plus 4x plus 7x and then plus 28. And I can figure out the common factors for every row and every column. X and 4 here, x and 7 here. And there it is. Again, get familiar with the Punnett square, even if you know that shortcut, because it doesn't work for every quadratic. So now looking at this, when you're submitting your answer, the order you put it in doesn't matter. So I'm going to put x plus 7 first. All right, and there we go. Notice they use x plus 4, x plus 7 right here as their answer, but x plus 7, x plus 4 is the same thing. Okay, if you have questions, if you want to see more examples of this, certainly stick around, let me know. if you feel like you're good to go, you're just doing some delta math tonight, and you should be good to go with that. All right, good luck.